So I know that some of you are asking about the midterm grades. So tomorrow, or in worst case Friday, you guys will get your grades, okay? Is there any other question? Is there any other comment? Labs are going okay? Okay. Yeah, and some of you asked about like uploading the lectures of the ones that I didn't upload. So I'll try my best to upload this tomorrow or on Friday as well. Okay. So on Monday, we stopped here and I asked you to try to implement this example at home and see what happens, right? And the main point behind this example is what we call polymorphism. And what does it mean? It means that one method, it can have multiple shapes based on what is the object that you are referencing, right? So especially with inheritance, you have one parent class, similar to the graphic object that we have here. You have multiple childs. And this is a very good example of how you can leverage this to write professional programs in a very, very easy way, right? So what we have done in this example is we said one method that we called area. It's a method of the parent class, but how you calculate the area depends on the shape itself, right? So now it's child dependent. So the implementation will depend on the child type. But then on the other hand, during runtime, you are able to call it from either the parent or the child using exactly the same syntax. And then the compiler, the language will know which area you are referring to based on the object that is referencing this method, right? So it's a very neat way. Like you write a very short program like this and it creates fantastic things behind the scene, right? So what do we do here? I assume at least some of you try to implement this. So can someone remind us, what do we do here? Did anyone try this at home? Like, would you please raise your hand? One? Just one? Two? Maybe? Okay, so I don't know, we are almost at the end of the course, right? But what I have tried to do is to make this as practical as possible because this is programming. You will never learn while you are listening to me, right? What I say actually doesn't matter. What you do is what matters, right? We do this in lab. I try to do this in quizzes. But also you guys should exercise because I don't have enough time during the lecture to implement every example we have, right? And honestly, I personally feel sorry that I just keep explaining code that is written here and then you guys don't write it. Because I know it doesn't matter, right? What matters is what you write. But we only have 50-minute lectures. If I ask you to, especially because you guys are so fast in writing code, if I ask you to write an example and we take 10 minutes, I don't cover the concepts that I would like you to know, right? So if you want to help yourself learning programming, if you want to get the best out of this course, I said this before multiple times, you should try to write as much as you can. This is how you learn, right? What I say doesn't really matter. And you will not get the concept. It may seem very easy when I say it, but when you write it, actually when you test whether you understand it or not, right? The same thing for quizzes. Like quizzes now are building, we are kind of creating a mini project that each quiz is building on top of like the previous one or two or multiple. And then if you don't go home, assume you didn't do very well in one quiz, and you didn't go home and try to write the correct program for the quiz, then in the next quiz you will not do well because the quiz depends on the previous one, right? This is another way that I'm trying to enforce you to go home and write some code, right? So make sure you do this. So maybe I'll ask the other question, like who did try at home to implement like quiz 8 that we had before to make sure it's correct or try to modify it? Can you please raise your hand? 1, 2, 3. The remaining ones, are you sure that whatever you did for what you did in the quiz is correct? Or you don't even care? Okay. Anyway, if you want to learn, you should try to teach, and this is not about this course only. This course is a kind of an extreme example of this. If you don't practice coding, it doesn't really matter, but all other courses in engineering are supposed to be like this. If you don't do things yourself, you don't get the best out of the lecture, right? I know you are very busy, you have other midterms, other quizzes, other projects. I know how engineering life looks, right? But if you just keep like wasting your time and energy in the cycle without doing what really matters, then you should think of how you manage your time, okay? So for those who try to write this down, the only single person that is here, can you explain to me what do we do here? For a bonus mark, given that you are the only one who did it. Yeah? Who said, like, I guess someone said here that he tried it at home? Yes? No? Okay, so what do we do here? Yeah, go ahead. Yeah, 5 types, 5 types, 5, yeah. And then? Yeah, after the for loop, we have a print statement here. Yeah, this one, right? So how does this code work? This code is the elegant part of polymorphism. How does it work? Yeah. Sure, thank you. So the thing here is this GI thing, this is an array that we created using, first of all, we defined it using the parent type. Then later, we assign each element of the array a certain child type. One is point, one is rectangle, triangle, circle, and then graphic object, I guess, is the parent as well, right? And then we calculate, we have a method here in the test class that calculates the largest area. So now we are comparing the areas of different graphic types. We are comparing the area of a circle with the area of a rectangle. How do we do this? The good thing about polymorphism is you can use exactly the same syntax. So here we have a loop, and then by just saying gi.area, during runtime, what is gi? GI can be a rectangle, can be a circle, can be a triangle, it can be anything, right? And then how does the language know that here you are calling the area of the circle, the area of the rectangle, the area of the triangle, based on the GI type, right? And this is the dynamic binding concept, is which method is being called is determined during runtime, right? If we don't have this capability, what we would do instead, assume, for example, in C, you have to define your own, for sure in C, this will be structures, but it doesn't matter. You have to create an object of a circle that is different than triangle, that is different than rectangle, that is different than point. And then you have a separate function for each one that creates the area, right? And then you compare each one separately. Now, with just a single line of code here, right, we are able to call the area method of the correct type without even caring about this. Why does this work? Because all are childs of the same parent, right? Actually, if they were childs of different parents, this wouldn't work, right? This will work because GI, if it's type circle, it's also a type of graphic object, right? We said this before in inheritance. Any child, any object of a child class is also an object of the parent class, right? So a circle object is also a graphic object, and then a triangle object is also a graphic object, right? So that means now you can compare things of the same class, because at the end this is why we have this figure here. Any instances or variables or objects of this type is also a graphic object type. This is why it's okay to compare this and this and this, right? Because at the end, they are the same thing. Is that clear? Okay. So now a question may come. These are extending like these ones, this is a child of this class, which means this extends this extends this extends this, right? But what does this extend? Or before inheritance, we just wrote classes without any extend thing, right? It was just like standalone classes. In Java, any class is by default extending a certain class in Java language, right? So if you wrote a class, for example, before we wrote the class point, and this wasn't an extension of anything, any class by default is extending a class in Java that is called object class, right? So there is a default statement if you don't define your class as a child of something, it's by default all classes are child of one parent. You can think of object as like the grandparent of all classes in Java, right? So it's like a tree, everything is starting from the object class, right? Good. And then some other things related to inheritance and classes is you can use an operator that is called instanceof, and instanceof is similar to in C we have something similar to calculate the type of. It's called type of function, right? Here we have an operator that's called instanceof, and this is checking whether an object or a variable is of a certain type of class or not. For example, you can check, assume we have a circle class and then we created a myCircle object, then myCircle, is it a type of circle? True, right? So it returns true or false based on whether a certain object is of a certain class type or not, right? So some examples here. So all these are extending this. And as I said, graphic object is also a child of object by default. So if we check, and I already said this, any object of this type is also of graphic object type. So if you say now you created a t variable of type graphic object, and then you assign it to be my triangle. So t is an instance of my triangle. True, right? Because what do we do in this line? We create an object. Again, you need to understand this. This is the main single statement that you need to know about Java. What do we do when we create an object of a certain class? You do two things. The first one is you, using the new reserved word, you create a place, you allocate a place in memory for that object, and then you make a reference to it. So we call this reference, we call this object. Object is the actual thing in memory, reference is the name that you are referring to. A reference is another form of pointers in C, right? And you can think of the object as the actual value itself in the memory. So here we create an object in the memory of type myTriangle, and then we make T pointing into it. T is of type graphic object. Is that allowed? Why it's allowed? Yeah, someone else? Why this statement is allowed? This is a class that is different than this one. How can I create a reference of a certain type and then make it point to another type? Yeah? Yeah, this is like casting because this is the parent of this, right? So it's allowed because now you are making a parent, a reference of type parent, referring to the child, and we have discussed this before, right? Good. So is T an instance of my triangle? That's true, because it's pointing to an object of type triangle. Is it also of type graphic object? That's also true, because by default, even if you may think that this is true, because T is created or not created, T is declared as of graphic object type. But what if, here is a question, what if I said my triangle T equal new my triangle? Would this statement would still be true? T in instance of graphic object? Yeah. Exactly. It would be yes, because I said before, any object of the child type is also of a parent type, right? So this is true. Like T in instance of graphic object is true, not because we declared it as graphic object, it's because also my triangle is a child of the graphic object, right? But the other thing that you need to understand is, what if we have two childs of the same parent? So here, T in instance of my rectangle. My rectangle and my triangle both are childs of graphic object. I created an object of type triangle. Would this be of type rectangle as well? No, right? The relation is between parents and child. We have no brothers in inheritance, right? Is that clear? So T is not of type my rectangle, even if both are childs of the same parent. Good. And then by default, everything, any reference would be an instance of object, as I said, would be true, because object is the parent class of everything. Is there any question? You guys were interactive in C much more than Java. I don't know, what is it? Are you exhausted at the end of the semester? You have to make a balance, because the final we already had C in our midterm. That means the main load in the final would be on Java, right? So if you didn't start studying or you have problems with Java, you need to try to handle this, right? Okay. Another thing that is related to inheritance is final. Why it's related? Because we will see now final will. One of the main things in inheritance is you want to know whether a method of a parent is inherited by the child or not. And we said by default, any method, any instance field is inherited by the child except, do you remember what was the exceptions we had? Are private variables inherited by childs? No, protected are, right? So if you have any variable of type of using a specifier private, it's not inherited. That means we have certain elements in the parent that are not inherited by the child. So what we said before, which is anything that is the parent has access to, the child would be having access to, this is not completely true, right? Because there are some variables and also maybe some methods that are not accessible by the child. Those that are private are not accessible by the child. We'll see now if you declare something as final, the word comes final because that means you cannot extend it. I don't want to extend it anymore. That means the child will not have access to this, right? The child will not be able to extend the method that is final or a variable that is final at the parent, right? So if you declare a variable that is final, this variable is not modifiable by the child, or the method is the same thing. If you declare a class, now this is about instances, instance fields, and instance methods. What about the class itself? If I declare a class as final, what you expect to have? You cannot even create a child out of this class. So this class is not extensible, right? So you cannot create a child out of this parent because it's a final class, right? And by default, all fields and all methods of a final class are final because you cannot create a child out of this, which means by default a child will not be able to modify them, right? Well, like a class that is declared final cannot be a superclass. A method that is declared final cannot be overridden. You remember overriding, right? A child is able to override a method in the parent by doing what? As a child, how would I be able to override a method in the parent? Come on. Yeah, write exactly the same method using the same input parameters, right? And then change the body of the method, right? By this, you're doing an overriding. So if you declare a final method at the parent, then the child cannot override this method, right? So you kind of create a protection from some modifications that will be done by the child. I already said this before. Any class that is final, all the methods and variables are final by default. One example here is the math class from the Java language. It's created as final because the language doesn't want you to modify the implementation of a power function or a sine function. These are standard things. They don't want you to modify how they are implemented. On the other hand, for example, in other object-oriented programming languages, because you may ask yourself, why someone would like to modify like implementation of power, right, or something like that. In C++, for example, you can even overload the assignment operator, right? So you can say, you know assignment operator, like int x equal y, this assignment operator. using object-oriented programming in C++, you cannot even make equal mean something else, right? So you can override almost anything, right? Here in Java, one of the main concepts behind Java is to make it easy to program. I mean, they intended to, no matter what happened at the end, but they wanted to make it easy as easy as possible. One thing is they prevented the overloading and overriding of many things. The second thing, I don't know how I didn't receive this question so far, is can we create a child of two parents at the same time, right? Each lecture, since we started inheritance, I was expecting this question, but I didn't get it. So now we have a child of a parent, right? And we said before that this parent can also be a child of something, so you can have a chain of a child objects, right? But the thing that we didn't touch or didn't discuss, can you have a child of two parents? So can you create a class that's a child or extending two classes at the same time? In Java, this is not allowed. Why it's not allowed? Because also to make it easy to program and to compile. But in C, you can do this. In other programming languages, you can also do this. Why I would like to do this? What do you think? Why do inheritance at the beginning? Like, what is the main point behind inheritance? Yeah, if there are, like the example we gave is there are some common features behind certain objects, then you make this as a parent class, right? Now, if you have two parents that intersect with certain features, and you want a child that takes the features of both classes, this is an example of why you would like to create a child of two parent classes, right? In Java, you cannot do this. There are workarounds, but the easy way you cannot do this, right? In C++ or other languages, you can. Okay, final methods, classes, hiding static method. Yeah. So the other thing is we discussed final. We said private are not accessible by the child. Protected are. What about static methods? Because you remember we discussed static methods and variables at the very beginning. What if, as a parent, I have a static method? Would I be able to override as a child? First of all, let's ask, what is a static method? Yeah. Yeah, it's created in the memory once you define the class, and it remains during this time. This is one thing. There is one very other important feature in a static method. What is that? Yeah, because there is one memory location for this. And to say what you said, what you said is a result of something else, which is a static method is not related to a certain object. It's related to the class itself. So if you create multiple objects, every one of them is trying to modify a static method or to update a value of a static method or call a static method. The change will reflect on all other objects because a static method or variables are not associated with a certain object. Rather, they are part of the class itself. Right? There is one single place in memory for a static method. Good? Just given this definition, now you can imagine that static methods are not allowed to be overridden by childs because it's just one single instance. Overriding means you have two things and one is overriding the other, right? A static method is only one location in memory, right? But what happens if I try to define exactly the same method in the child and originally it was static at the parent? What would happen? You would create another place in memory using exactly the same name, but now you have two static methods, both are with the same name, same input parameters, and if you call this within the child, then you are referring to the child one. If you want to access the other one, then you use super.something, right? And there is a very big difference between this hiding concept and the overriding concept, because I know this is confusing. So let's have an example that explains this thing. So here we have a my super parent class and then my subclass. And then inside the super one, we have two methods. One of them is static, the other one is just normal instance method. And then I try to override or have the same name, same input parameters as the child. One for the static and one for the instance method. And then here I have a testing a program that creates some objects and then try to call this. Would you please implement these right now, given that you guys are sleepy? Like, I'll give you 1 minute, which means it's like 2 minutes, to write this, and let's see what happens. What is the difference between static and an instance method? If you are done, then write this test class as well. Okay? And you guys already have the slides. Both are, because you remember, and this. Is there anyone done? Yeah. What did you get as an output? Did you get the same thing here? Yeah. Can you explain to me why do we get this? For a bonus mark? Yeah, so let me first show you something, because what you are saying is correct, but I am looking for a certain statement. Right. Okay, a second. Okay. So, first of all, we discussed, I guess in the past 2 lectures, what do we do here, right? What do I do is I create an object in the memory for the type my sub, right? This is subclass. And then I create B is also type sub. But then in the second line here is this one. I create another reference, but this one is of type super. I make it also pointing to the same place in memory. If you don't understand this, ask, right? This is very critical. Good? By just doing this, we will have some confusion on what you said, right? So based on this figure, can you explain to me what did you say again? Yeah, let's start by the first one, b dot static toString. Good. Yeah. Good. Good. What about the last one? The last one is the most interesting one. Yeah, but here, like Q is of type my super, right? And this was your reason to say that here we are calling the super one. Why here I'm calling the child one? Yeah, that's correct. Thank you. Just to say it in a simple word, and like what is written here. So if you understand this, let's say the following 2 statements, right? We said before, for instance methods, overriding by default, what happens is you are referring to the method based on the object type, right? So even if Q is of type super, but it is pointing to an object of type sub. So if you say Q dot instance toString, Q is of type my super class, but it's pointing to a subclass. So the method that we are calling depend on the object type, not the reference type. You need to understand that we have 2 different types here. The reference, which is the name of the variable, and the object, which is the actual thing in the memory. The object, we have a single one, which is the subtype. But for reference, we have 2 different references. One of subtype, the other one of supertype. On Monday, I said the method that you call depend on the object type. Forget about the reference type. And this is why even Q is of my type, my super. When you call Q.instance toString, you call the my sub one. Is that clear? You should have known this from Monday. Good. What is different in static and what may be confusing? In static, you do the opposite thing. Is the method that you call not of the object type, it's of the reference type, right? So here, if I say Q.static toString, which is the static method, now I look into the reference type. It's a super one, and this is why I go and call the super one, right? This is a difference between hiding, which is applied in static methods, and overriding, which is applied on instance methods. In overriding, you call the method of the object type. In hiding, which is for static methods, you call the method of the reference type. Is it still confusing? Do you have any question here? it's this one. Yeah, like what I have here. Always, if you don't use new, we don't allocate a new place in memory, and it's pointing exactly to the same memory location. But with some differences here. Remember when we did this the very first time, I told you that even if you are pointing to a subclass and you are a reference of a parent class, you don't have access to the specific methods of the child class, right? So you are pointing to the same place in memory, but you don't access everything. Yeah. The static both access the same way. What do you mean? Not the same method. These are two different methods, right? And these are two different places in memory. Even for overriding, you have two different methods, right? It's not that you have just one. But the point is, when you create a child type, you are only creating in the memory one place for the instance method, which is the child one. But for static, you always have the parent one and you have the child one. But you're only, if you are within the child, you are only accessing the child one, right? Is there any question? Okay. So the same thing applies for hiding member variables. If you have a variable in, and we had this before, if you have a variable in the parent and then you have the same name for the variable in the child is going to hide the value of the parent. What if I want to access the one at the parent? What should I use? The super reserved word, right? One example here is we have our superclass, we have our subclass, then we have an integer value that is called x value, both in the parent and in the child. This is a public one, so everyone has access to it. But if we have it as protected, also it's the same thing applies. And then we have our constructor here that sets the value of x value to 10 at the parent, 100 at the child. And we have here our getter for x, and we have two gets here. One for the child, which is the default one. But then we have another getter, which is the one that wants to get the parent value of x. How would I do this? Using the super reserved word. So this is why we call it get super x, right? So we return the super.x value. What is the difference here? This one, by default, if you just say x value, you are referring to the one that is at the child, right? Remember, this is similar to if you have one, we had something very similar to this example before. Can someone tell me what did we have before? This has nothing to do with inheritance. But something very similar, but yes, yeah? Yeah, and then what happens? Exactly, yeah, thank you. So we said if you have one class, then you have an instance field, int x, for example. Then you have a method that also defines int x. That means you have a local variable and an instance public variable with the same name. If you are within the visibility of the local variable, which is inside the method, then the local one hides the global one, right? What if you want to access the global one, even inside this method? You use this dot x, for example, and this is going to give you the member field of the class. Exactly the same thing. You have a child, you have a parent, then by default you access the one that is at the child. If you want to access the one at the parent, you have to use super dot x, right? Or here x value. Good? Great. So this is just like a test class. Here we create an object of type mySub. Then if I say x value in the subclass is sub.getX, sub.getX is calling this function, which is returning the x value of the child. But if you want to get the parent one, you have to access this method, which is calling super.x value. Okay? So why you get 100 and then 10 here. Is there any question here? Okay. So we mentioned object before. We said object is the parent class of all classes. Object has some already defined methods. If you apply the same rules of inheritance we covered so far, if you don't redefine these methods at any class, what would happen? What do you think? I just created a class. Has no method at all. What's going to happen? If you created an empty class, has no methods, would it have a method that is called toString, for example? It inherits them from the parent, which is the object here. So that means by default, every class you create has certain methods. So for example, in an interview, if you are asked these kind of tricky questions, I just create an class, how many methods does this class have? By default, you say 0, right? Because it's just an empty class. That's not correct. Why? Because it inherits everything from the parent, which is the object class, and any method within the object, you get it. So including clone, finalize, equals, toString, get class, these things, right? So let's see how would this happen. For example, we already have the graphic object class from the one that you implemented, supposedly like implemented at home. And then this one, if you just say g.getClass, we didn't create a method that is called getClass in our graphic object class, right? But then it will return you something, which is the name of the class. How did this happen? Because this is a method that is inherited from the parent, right? Another thing here is also using toString. But the problem with toString is if you don't override the toString method, it just returns to you something that is like not easy to get. It returns the class name and then something else, like most probably it's a memory address for something, right? So this is why usually a good programming practice is you make sure at least if you are going to use the toString method, you override it in your own class. Good? Is there any question? Okay, so by this we are done. Tomorrow we will continue also things that are related to inheritance and Java, and then next week we'll start a topic that is slightly different, which is data structures, but also we will see how to use data structures within our context of our mini project thing. Thank you.